Okay, so I'm back, and today we're going to speak about transistors. Everyone knows about transistors. At least everyone has seen them. Black colored semicircle, 3-terminal, some small component. Yeah, okay. So we're going to talk about that. So before we got to talk about transistors, everyone knows what are conductors? What are they?
Just energy.
Okay.
They facilitate the flow of electrical energy.
Okay.
They allow an electrical current to flow through it.
Okay.
I guess material with low resistance.
Okay. Yes, all of you are right. Conductors allow the electricity to pass to them, and they have a very less resistance. So what are insulators then? Yeah, opposite. Right. They don't allow electricity to pass to them. So if conductors allow and insulators don't allow, then what are semiconductors? Has everyone heard about them? Yes, Peter. What are semiconductors?
They act as a bridge between insulator.
Yes, so basically sometimes they allow electricity to pass to them and sometimes they don't. So they act as both. So why I ask you about semiconductors? Because one of the important component diodes that everyone knows, right? That it allows the current to pass only in one direction. Does anyone know how? Why? Why does it allow electric current only to pass to in one direction?
Because it provides a lot of resistance for it to go in the other direction, so
Yes,
the current will
why?
always flow one way.
You know the internal mechanism, why it provides resistance in one direction, like very low, and in another direction very high.
Doesn't it provide a buildup of electrons on one side and holes on the other, which would already make the current want to flow in the direction desired?
Yes, that's correct. So that's what he said. So basically, everyone knows that this is the diode, right? But the diode is made up of two types of semiconductors. One we know as P-type and N-type. P stands for positive, N stands for negative. Now, how do we make these type of semiconductors? Basically, we just take an insulators. For example, silicon and germanium. Everyone know that they are insulators. They don't allow electricity to pass to them. Why? Because they are very stable elements. They don't have any free electrons in their valence band. Since they don't have any free electrons, therefore they are very stable and they do not allow any electricity to pass to them. Now, to make these stable elements as semiconductors, what we do is that we add impurities into it. What are impurities? We add metals that will give them that extra valence electrons for them to conduct electricity. So what these types do is that P-type, germanium and silicon, these are the two semiconducting materials where after adding impurities into them, they can act as the semiconductors. They both have stable octet, they both have 4 valence electrons in their valence band. That means they don't have any free electrons to conduct electricity. Their bond is very strong and therefore you require very high energy for them to conduct energy. So what we do is that we add impurities. For example, for P-type, it means it is a positive. That means we add some impurities, for example, like gallium and indium. These are the two metals that we add into germanium. These both have only 3 electrons in their valence band. So 4 plus 3, 7, right? It's short of 1 electron. That means it creates a hole. Hole is positive charge, therefore we know as that P-type. This hole will be used for conducting electricity. I said yesterday that holes are absence of electrons, so in P-type we have excess of holes in the metals. Similarly in silicon, what we do is that we add impurities like antimony and bismuth. These have 5 valence electrons in the valence band. 4 plus 5 is 9, right? You require only 8 in the valence band to be stable. So we have 1 extra electron. That 1 extra free electron will be used for conducting electricity. This is how you convert these insulating materials into semiconducting materials. We got two types of semiconducting materials, P-type and N-type. How the diode is formed is that we mix them together. Mix, literally join them. P, N. This is the internal structure of a diode. take P type of semiconductor, N type of semiconductor and mix them. Now we know that these P type has excess of holes, right? And these have excess of electrons. When you mix them, near the boundary there are some electrons that will combine with these holes, right? They have affinity for combining with the positive holes. So these electrons will diffuse into the P region and the holes, it will diffuse with the holes. So a very thin layer where the electrons will jump and therefore there will be no charge here, right? It will keep on combining till it reaches a stage where the electrons from this region cannot overcome this barrier. To overcome this barrier, it needs now extra energy. This is very stable, it does not have any extra electrons or holes for it to combine more. So for these electrons or these holes to move in this region, it requires no extra energy. That extra energy would be equivalent to this barrier that is created. Okay? Now, imagine this is your diode. I mean, these two are equivalent. I'm just showing you how it is internally. This connect the anode to positive and cathode to negative. It will conduct, right? How? Yeah?
Like closes the gap because you got a positive pole connected to the anode, which forces them across the barrier.
Yes. So the condition for this diode to conduct, the potential that you applied should be greater than this, right? We want these particles or these electrons and holes to overcome what this potential is developed. So this battery we applied, which should be always greater than this potential, and once it is greater than that, they get that much force and they cross this barrier, and that is how it conducts electricity. Now, if you connect this battery in the reverse direction, what will happen? Now what happens is that here we have holes, right? And here we have electrons. Positive, negative. They try to attract these ones. Right? Take them apart. This increases more. These holes will be attracted to this negative terminal of the battery, right? Since opposite attract, they will take them more far away and this potential will be increased more.
Can you like drain a diode by connecting it the wrong way to a battery? Because you'd like force the, at least on the negative side, you'd force the electrons to battery, the positive end of the battery?
No, we cannot drain it because I said that these excess electrons are already present. When you make an N-type semiconductor, they are already present. So it doesn't depend upon your battery. This will just facilitate them to now move in this direction.
But I mean, if you had a positive end to that battery and it was connected to a buildup of negatively charged electrons, why wouldn't they just move to the positive end of the battery?
I mean these ones?
No, the ones connected to the battery.
These ones?
Yeah.
And you're telling that they should go like this?
Yeah, why wouldn't that happen?
No, it wouldn't happen. What it does is that there is always, for them to move in this direction, right? There should be some diffusion, right? The circuit should complete itself. The path should complete. You cannot have excess of electrons going here and nothing coming out here.
Okay.
If it happens, that means there should be some electrons that will be jumping to this, right? To complete the circuit. You cannot have that you adding 5 electrons here and taking 5 protons here, but they are now decreased. You have decreased these 5 portions, so you have to increase them. The amount that you add the electrons here, you have to give them here, right? The circuit should complete, so you cannot do like that. Okay. Now, since you connect the battery in the reverse direction, it won't conduct. That is how the diode conducts only in one direction. When you connect the PN junction in the right polarity of the battery, it conducts only in one direction. That is how diode allows only the current to flow in one direction. It depends how you apply this battery to it. So when it conducts, and that method, it's known as that the diode is now connected in the forward bias. The terminology that we use to say when the diode conducts electricity, we say that it's in the forward bias. And if it does not conduct, then we say that it is in the reverse bias direction. It's just the terminology. It says that it conducts electricity and doesn't conduct electricity. That's it. Now, this was how the diode works. Why was I explaining why diode works? Because our transistors, they work in the similar manner. The transistor has 3 layers. Yes. There is one P layer sandwiched between the 2 N layers. And similarly, there are 2 types of transistors. Okay, there are actually different types of transistors. I'm going to talk about one of them, that is BJTs. That black color that we saw with 3 terminals, they are known as bipolar junction transistors. They have a name. In short, they are known as BJTs. They have 3 terminals, and there are 2 types of them, NPN and PNP, where N is sandwiched between P layers. So how do you denote them? What is the symbol of transistors? Does anyone know that? Okay. This is how you denote when you are making a circuit diagram. This is how you will see that the transistor is being made in the circuit diagrams. It's still incomplete, as in when we move forward we will see. Okay, so when a transistor is being made, these 3 terminals have a particular name. You cannot say them NPN. Each has their names: emitter, base, and collector. These all 3 terminals have their names: emitter, base, and collector. So in diagram you have to label them: E, B, and C. Okay? I'm going to explain the working of NPN. The working of PNP is same. It's just that it will be in the reference with holes and will be in the opposite direction. So first I'm going to explain what happens here. Forget this part right now. This is a diode, right? NP. That's what I explained. When you just combine them, a barrier will be created, right? Similarly on this side also there should be a barrier created. These are axes of electrons. These are axes of holes. And these are also again axes of electrons. Now, actually what transistors are, they are also known as current control device. So main application of transistor is that you can control the amount of current flowing in the circuit. If you want more current to flow, this is the transistor is used in the circuit to just control how much quantity of a current you need to flow through the circuit. Whenever you want something, any component that you're thinking of that should control the amount of current in the circuit, this is the component that you should look for. There are different types of it. I'm explaining how it works. Now the emitter. When we make the connections for transistors, you always have to connect base emitter junction in a forward bias connection. I explained that this is a kind of a diode, right? So in the forward bias condition, this has to be connected to negative and this has to be going to the positive. Now imagine this is a diode. Is it connected in the forward bias? Yeah, it is. Sorry. Yes. So what happens is that since it is in forward bias direction, this part will conduct electricity. It has now that much force to diffuse in this region, right? But this region has many holes in it, right? So it will take up all the electrons that is coming, right? It will try taking all the electrons in it. That means in the transistors, this region is made very thick because What is our aim in transistors? We want maximum electric current to flow from emitter to collector. That is how it will conduct, right? We want the current to flow from emitter to collector, and it should be very high. And that is what our purpose is. So to make that purpose, we need to have a very small layer of P region, right? If it is very big, then it will take away all your electrons, which we don't want. In spite of having less holes, and there are many electrons, right? So there will be many electrons that will be passed into this region. So now we have reached a state where the electrons have crossed this P region, since we are connected in the forward bias direction. Clear up till now? Any doubts? Yes? No? Or understood everything? Okay, understood everything I assume. Now we want that this collector should conduct electricity. For that to do it, we always connect the collector and base junction. Again, it's like a diode, right? Always in the reverse bias direction. Always. So N region will go to the positive terminal and P region will go to the negative terminal. Now we saw that the electrons have reached here. Now we want these electrons to complete the path. That is why we want to connect it to the positive. It will attract, right? We have lot many electrons coming here, and this is full of N region. It's full of electrons. We want it to conduct now. That is why we are having a high voltage battery, and we are making it lot more reverse biased. And that is why this part will attract all your electrons and it will conduct electricity. This part will help it to overcome this barrier and reach your collector. This will help it to attract that electrons and it will conduct. This will, yes, take some of the electrons into it. That's why we make it as thin as possible, so that we don't lose most of the electrons. Yes.
So, why don't all the electrons just go out through the positive and
this, right?
through the base? Yeah,
From
like
the
why
base.
would they jump over to the negative
Yes.
side?
That is also a question. So that is why what they have designed is that the actual design of the transistor is that depends upon the size of emitter base. The emitter is so big, base is really thin, and collector, since it has to accommodate so many electrons, the collector is of bigger size. This is really thin. I mean, if you say that there are 10,000 electrons coming, the holes will be just 10 of them. And the amount of holes that gets diffused here, equal amount of electrons will also be created here, so that the circuit should be completed, right? That is why we make this very thin, and therefore most of the electrons do jump. And that is why we have this battery that will allow them to jump and get that much energy to pass through this barrier. This is how the transistor works. We got that the electron is flowing through it in spite of connecting this in the reverse bias direction. So I was talking about this is still incomplete, the symbol needs to be completed. We saw that in NPN transistor, how do you tell the person who is reading your circuit that whether the transistor you have used is NPN or PNP? Since in NPN transistor the emitter is N, right? The electrons are moving from N to P region, right? That means when you show the current direction, it should be in opposite direction. So the current flows from base to emitter. This arrow, very important. If you forget this arrow, the person won't know that whether you have used NPN transistor or PNP. In NPN transistor, the electrons flow from emitter to base. That means the current is flowing from base to emitter. That's what I showed. You always show the direction of the current. Now you don't need to specify that whether it's NP or N. This arrow gives you all the sufficient information that you need whether the transistor is NPN or PNP. If it is PNP, N, that means the electrons will be diffusing from base to emitter, and therefore the current will flow from emitter to base. This is the direct final symbol. There are two applications of it. One was, I said, to control the current in the circuit. One is that it also amplifies the signal. These transistors can be used for amplification, and also it can be used as a switch. These are the two applications. I'm not explaining you how does it work, but if anyone is interested, I can explain them in person because I don't want to go in that much depth right now. And also there are different types of transistors. I explained you bipolar junction transistor. Bipolar means it has two polarities, N and P. Junction because it is forming a junction, and that is how it got its name, bipolar junction transistors. There are two more, JFET, which is junction field effect transistors, and MOSFETs, which is metal oxide semiconductor field effect transistors. You don't need to remember them. If you're using them in your circuits, we'll surely come and explain to you how does it work. But these are the basics that you should know how does transistors work. Any questions?